Differential equation. We have today has discussed definition, degree and order of the differential equation, and formation of differential equation here. Look here, what is the definition for the differential equation? Differential equation means it's an equation involving with one dependent variable, and as derivatives with one or more independent variables. Is called a differential equation. If y is equal to f of x is a differential equation, is an equation. Y is a function in x, so y is depending on x. So here x is independent, y is dependent. If z is equal to f of x comma y, z is a function in x and y. Z is depending on two variables. Z is dependent variable. The independent variables are x and y. In case of ordinary differential equation, partial differential equation, we will have x and y. Here it's a simple differential equation. We depend on only one variable. We are discussing differential equation, ordinary differential equation. So it has a one dependent variable and one or more independent variables. Then it is called a differential equation. Here y dash dy by dx is denoted by y1 or y dash, or if y is equal to f of x, it is denoted by f dash of x, y dash or y1 or f dash of x. These are the notation. D square y by x square is y2 y double dash f double dash. So y double dash plus 6x y dash minus 6y plus minus 3 equal to 0. Equation involving with the derivatives. Equation involving with the one dependent variable as a derivative with one or more dependent variables. The equation with the derivatives. Okay, sin x into dy square y by dx square minus 9 cos x into dy by dx plus 6 tan x is equal to 2x plus 3 are the examples for differential equation. Here, degree of the differential equation. The differential equation must be expressed as a polynomial expression in x in derivative. So ax to the power of 1. You can see here x to the power of n plus a1 x to the power of n minus 1, a2 x to the power of n minus 2, so on. An, this is an nth degree polynomial in x. Polynomial expression f of x is an nth degree polynomial expression in x. So if these x's are in terms of derivatives, then it is called a differential equation. Then that differential equation will have a degree, or else the index of the derivatives in this equation must be positive index. They must be free from radicals. Means powers must be integers. Derivative powers must be integers. So equation must be expressed as a polynomial in derivatives, and the index of the differential equation must be positive integers, and the power of the variables of x and y need not be integers. Keep it in mind. Degree powers of the differential equation must be positive integers, whereas the x and y that is present in the differential equation may not be integers. They may be rational numbers also, irrational numbers also. So then, if these three conditions are satisfied, then we can write the degree of the differential equation. We define the degree as the least possible power of highest order derivative present in that differential equation. If there is a possibility to decrease the power, you have to decrease to its lowest power, such that you can find the degree of highest order derivative. Such degree is taken as the degree of the total differential equation. Okay, so degree of the differential equation is given. It must be a polynomial expression. Suppose y is f of x is equal to ax square plus e power x plus c It's not a quadratic equation. Quadratic equation in x, since e power x is there. Similarly, a differential equation must be a polynomial in derivatives. It should not, a derivative should not be inside logarithm, exponential, sine, trigonometric function, power of exponential, inside the logarithmic function, sine, inside the trigonometric function. It must be free from all those things. It must be a polynomial expression in derivatives. The index of the derivatives in this equation must be the power. Index means the power must be positive integer. If you are able to find such a least positive integer of higher then the highest order derivative, the differential equation will be there. It contains different order derivatives. Dy by dx of order 1, d square y by dx square is order 2, second order derivative, d cubed y by dx cubed is third order derivative. So highest order derivative, least possible power of highest order derivative is called the degree of the differential equation. Okay, right. What is the order of the differential equation? No need to think of all these things for the order. The highest order derivative present in the differential equation is called the order of the differential equation. So for every equation, order will be there. For the equations which are not in the form of polynomial expression, the equations which has uh, rational powers, radicals as powers, then such differential equations will not have degree. So if there is a possibility to decrease the radicals, you can reduce the radicals. So before writing the degree, you should not change the total equation. Okay, right. We'll move on to equation. Order of find the order and degree of the differential equation. Find the, look here. We have to find the order and degree of the differential equation for first one. What is first one? Dy by dx. Dy by dx is equal to x to the power of 1 by 2 by y to the power of 1 by 2 into 1 plus x to the power. So whatever may be the degree of x and y, no need to bother. We have to bother about the degree of the derivative. Derivative is free from radical index. Its least value is 1. There is no other least positive integer less than 1. So least 1 is 1. So this is a differential equation. So x and y may contain rational powers also. So this differential equation, I can consider this as a differential equation in polynomial. Therefore, degree is equal to 1. Order is highest order derivative, only one order derivative is present. Order is equal to 1. Okay, right. Second one, move on to second one. There is y2, d square y by dx square, 2 into dy by dx plus y is equal to log of derivative. It's not a polynomial in derivatives. Okay, so what you can conclude? So degree not defined. Okay, degree is not defined. So now next go from the order. What is the order of the differential equation? Order is equal to highest order d square y by dx square, that is 2. So degree is not defined and order is equal to 2. Okay. Third one, power. There is the derivative dy by dx whole square. Power is 5 by 3. Reduce the power. So y2 to the power of 3 cubing on both sides will get into 1 plus y1 square whole to the power of 5. Is there any possibility of decreasing the derivative powers? No. So I can conclude that highest order derivative is 2, power is 3. So degree is equal to 3. Order is equal to highest order derivative is 2. So order is 2. Okay. Right. Next we go for the fourth one. This can be written as y1 to the power of 1 by 2. If it get this side, it becomes 0. So plus y2 to the power of 1 by 3 is equal to 0. So y1 to the power of 1 by 2 is equal to minus y2 to the power of 1 by 3. 2, 3, LCM is 6. But take power 6 on both sides. This becomes y1 to the power of 3. Minus power 6 is positive. Y2 to the power of 2. Now we can conclude the value of degree as what is the degree? Degree is nothing but highest order derivative power. So that is 2. What is order? Order is the highest order derivative present in it. Order is 2. Is it clear? Right, next. Derivative is given. Differential equation is given. Here 3 by 2 is there. Derivative is there. Taken power, it becomes 3 by 2. So it should not be like that. So taking squaring on both sides, will get 1 plus y2 to the power of 4 plus 2y2 square, okay, is equal to 2 plus y1 square whole cube. So here it's an equation, polynomial equation. There is no possibility of decreasing less than this. So degree is equal to highest order derivative y1, y2. y2 is their highest order derivative power. Highest order derivative power is 4. What is the order? Order of the differential equation is equal to 4. Next we go for the problem. Let's see order. Here it is second order, no? So it becomes second order derivative. So order is 2. Degree is 4. Highest order derivative, that is 4. Okay. Highest order derivative power is 4. So next y2. y2 is minus p square y. So there is this constant y power. It may be of anything. So only 1 is there. So degree you can write directly as 2. Sorry, 1 is the degree. This is 1. Degree is 1. What is order? Order is equal to 2. Look here to go for the 7th problem. Here e power x is there. E power x may be there. So it's not inside the derivative. Derivative is inside x. So there is a d cubed y by dx square. I'll write like this. So power of the derivative is 2. Okay. Minus 3 into dy by dx whole square. No problem. Let us take this as a constant. You can write it as e power x plus 4. This is constant. Dy by dx is not inside the or not the power of exponential or doesn't lies inside the trigonometric function, inverse trigonometric function or logarithmic function. So it is a differential equation in polynomial. It's a polynomial in derivative. Okay. Now I can define the degree. Degree is nothing but 2. What is the order? Order of the differential equation is highest order derivative, that is 3. Order is 3. Next, go for the next one. Go for the next one here. 1 minute. X to the power of 1 by 2, y2 to the power of 1 by 3. Okay. And then x into y1 plus y is equal to 0. So what you can write this? You can write this as x to the power of 1 by 2, y2 to the power of 1 by 3 is equal to minus xy1 minus y. Cubing on both sides, this becomes x to the power of 3 by 2, y2 to the power of 1 is equal to minus xy1 minus y whole cube. The degree may be something, we doesn't need it. So here x to the power of 3 by 2 is there, maybe. So we are not depending on the power of x and y. It may be integers or may not be integers, so it doesn't bother about the x and y here. We bother about the derivative power. Derivative power dy by d square y by dx x square power is 1. Here dy by dx power is cube 1 actually. When cubing you get 3. So I can now define the degree since it's a polynomial equation. Degree is equal to 1. What is order? Order is equal to second order derivative. Highest order derivative in it is second order. Come here. It's an important problem given many times in examination. 6y power may be anything. So here 6 by 5 is there. I don't take powering power 5 on both sides. Send 6 by 5 totally to that side. D square y by dx square plus dy by dx Then given d square dy by dx whole cube, so it's equal to 6y. I send the total 6 by 5 to that side, so it becomes 5 by 6. So power of y can be a rational number, may not be an integer. So it becomes an polynomial equation in degree, in derivatives. Therefore, it's of the form d square y by dx square plus dy by dx whole cube is equal to 6y whole to the power of 5 by 6. Therefore, degree now it can be defined as degree is 1, since highest order derivative power is 1. So, and the order of the differential equation is 2, since highest order derivative lies here is d square y by dx square dy by dx. Among these two, order 2. If formation of differential equation. Formation of differential equation. How can you form a differential equation when an equation is given? If the equation of a given family of curves contains n parameters, so if it contains 2 parameters, then we have to differentiate 2 times. Since if the equation of family of curves contains n parameters, then we differentiate the given equation n times successively to eliminate the n parameters. After eliminating the n parameters, the equation obtained will be of order n. Means nth order derivative will be present, so order of the differential equation will be n. And that is said to be the differential equation. Hence, the order of the differential equation will be equal to the number of parameters present in the given equation. Vice versa. If there are n parameters, the order of the differential equation is n. If the order of the differential equation n, then if you simplify or solve the differential equation, it will contain n parameters. Okay, so we go for an example and then we can understand easily. Let's look into this. Find the order of the differential equation obtained by eliminating the arbitrary constants. Here arbitrary constants are b and c. Given arbitrary constants are b and c are the arbitrary constants here. So given equation is, what's given? Given equation is xy is equal to c e power x plus b e power x plus x square. Differentiate xy1 plus y into x derivative 1, uv formula for this. We know that the derivative of e power x is e power x and the derivative of e power x is e power x plus 2x. Derivative of this is 2x. Now we can replace this with here it is minus x, so it becomes minus bx. So xy1 plus y is equal to c e power x minus b into e power minus x plus 2x. Again differentiate, we'll get into xy2 plus for this xy2 plus x derivative is 1 and then y1 derivative is y2, x into y2, y1 into x derivative is x 1 and then again y derivative is 1, y1 is equal to c into e power x derivative, again minus of minus plus b e power minus x plus 2x derivative is 2. So what is the value of c into e power x plus b into e power x from equation 1? xy2 plus 2y1 is equal to, I replace this with xy minus x square plus 2. Now we can conclude the answer like this. Order is xy2 plus x into y1 is equal to xy minus x square plus 2. That is the differential equation. So order of the differential equation is 2 since there are 2 parameters. Next, come here. Find the order of the differential equation of the family of the circles with their centers at origin. So order of the different, we have to find the order of the differential equation. This is what we have to find. For which we have to find the differential equation of the family of the circles. For the family of the circles whose center lies at origin. If the center lies at origin, which one varies? So center is fixed. So changes in radius. So we have to find the equation of concentric circles. What is the equation of the circle? That we can assume is x square plus y square is equal to r square. X square plus y square is equal to r square. So the origin is center, radius is r. Since it contains only one parameter r changes, therefore we differentiate once, so it becomes 2x plus 2y1 is equal to 0. So y1, when you divide with 2, it becomes y1 plus x is equal to 0, or y into dy by dx plus x is equal to 0. That is the equation of the differential equation obtained from the family of the circles whose center is at origin. Second Roman in this exercise, form the differential equation of the following family of curves where parameters are given in brackets. This here C is the parameter. It contains only one parameter. So let us take the given equation as like this. Y is equal to C into x minus C whole square. Now differentiate this. Y1 is equal to C is constant. When you differentiate, it becomes 2 times of x minus C into x derivative is 1. Okay. Now square this. We have to eliminate C from this in order to find the differential equation. That is the condition to form the differential equation. Square. This becomes y1 square. C square, I can write it as 2 square is 4. 2 square is 4. C square, I can write it as C into x minus C whole square. Okay. So y1 square is equal to 4C into this, I can write it as y. This I can write it as y. So what is the C value? C is nothing but y1 square by 4y. Now substitute in the given equation. Therefore, y is equal to, what is the value of C? C is y1 square by 4y into x minus C value is y1 square by 4y. Okay, this is the way of solving. So you can end here, but as a student we have to simplify it. Y can be written as y1 square into 4xy. 4xy, there is whole square is there. C x minus C whole square. So 4xy minus y1 square whole square by LCM it becomes 16y square. Okay, here it is 4y. Here it is 4y. So I can write it as 4 into 16, 64. 64 y into y cubed into y is y power 4 is equal to y1 square into 4xy minus y1 square whole square. Take square root on both sides. 8y square is equal to y1 into 4xy minus y1 square. Still you can simplify it as 4xy1 minus y1 cubed is equal to 8y square, or else I can conclude here. Is it clear? Similarly, you can find differential equation of xy is equal to a e power x plus b e power minus x, and for this, or else take this, try this at home, try this, and now I can go for the differential equation to find the differential equation for this curve. What is given here? Y is equal to a plus bx e to the power of kx. Here the parameters are a and b. So how many times we have to differentiate? Twice. Since there are two parameters, we have to differentiate twice successively. So y1 is equal to uv formula. I keep a plus bx as it is. Differentiate e power kx, that is e power kx into k, plus e power kx as it is, and then a plus bx derivative is b. U v dash v u dash. Okay, right. Next, e power kx y1 into e power kx. I can again differentiate. So, or else you write like this: y1 is equal to, what is the value of this? A plus bx e power kx is y. So I can write it as ky plus e power kx into b. Okay. So this is equation number 1. So this is equation number 2. Y1 is equation number 2. Again differentiate. Y2 is equal to k into y derivative is y1 plus e power kx into k derivative, b is constant. Now e power kx into b, e power kx into b value, I replace e power kx into b value. So y2 is equal to ky1 plus k into e power kx into b, e power kx into b, e power kx into b is y1 minus ky. Can you understand? I eliminated a and b. Now this is set to be the differential equation. I just clear it. Y2 is equal to ky1 plus ky1 is 2ky1 minus k square y. K into k is k square y. This is the differential equation. Since it contains two variables, order is 2. Okay. Obtained the second Roman, second problem. Obtain the differential equation which corresponds to each of the following family of curves. So a family of curve is given in terms of word. A sentence is given. So what is the sentence? The rectangular hyperbola which have the coordinate axis as asymptotes. So rectangular hyperbola which has coordinate axis as asymptotes is this. So we know the formula as xy is equal to c square from hyperbola. It is the equation of the asymptotes, equation of the rectangular hyperbola whose coordinate axis are asymptotes. Asymptotes means the tangent which touches the hyperbola at infinity. So what is the equation of the rectangular hyperbola? Xy is equal to c square. This is the hyperbola which whose coordinate axis are nothing but tangents which touches the hyperbola at infinity. So these coordinate axes are called as asymptotes, right? Xy is equal to c square. Only one constant is there. So differentiate only once. X into y derivative y1 plus y into x derivative 1 is equal to c is constant, its derivative is 0. This is the differential equation. Simple problem given for 2 marks many times. Right. Second one, the ellipse which has a center at origin and having coordinate axis as axis. So I think everyone knows the equation as x square by a square plus y square by b square is equal to 1. X square by a square plus y square by b square is equal to 1. Differentiate. Since it contains two variables a and b, we have to differentiate twice. So first derivative 2x x1 by 2x derivative of x is 1, sorry, and then a square 1 by b square into y derivative is y square derivative is 2y y1 is equal to 0. 2 gets cancelled. So y1 by b square is equal to minus x by a square. Okay. Now differentiating on both sides. Differentiate on both sides. Differentiating on both sides, what will get? y1 into, again y derivative is y1 plus y1 into y I keep as it is, y1 into u into v dash. V into u dash is y1 derivative is y2 by b square is equal to minus This minus x derivative is 1, isn't it, by a square. Now how to do equation number 2? Twice we have differentiated, we have to end this. So there is y1 square. I multiply with the x on both sides. So that x y1 square x y y2 by b square is equal to minus x by a square, isn't it? Minus x by a square from equation 1, this can be replaced with y y1 by b square. Both sides y square b square gets cancelled. Therefore equation what we get is x y1 square plus x y y2, and this is y y1 minus y y1 is equal to 0. There is the equation. Okay, right. Next one, go from the Roman number 2, Roman number 3, first problem. Roman number 3, first problem. Form the differential equation of following family of curves where parameters are given in brackets. So first equation is given. We already done like this such type of problems. A into e power 3x plus b into e power 4x. Okay, so differentiate once. Y1 is equal to, here the parameters given are a comma b. So we have to differentiate twice since two parameters are there. Y1 is equal to a into e power 3x derivative e power 3x into 3 plus b into e power 4x derivative e power 4x into 4. I think you are clear. Then next one, again differentiate. What will get? Y2 is equal to a e power 3x into 3 again becomes 9 plus b into e power 4x into 4 becomes 16. This is equation number 1, this is equation number 2. Multiply this with 4 and then subtract. There is 4y1, isn't it? 4 into y1 minus y2. There is 12 minus 9 is 12 minus 9 is 12 minus 9 is 3a e power 3x. 16 minus 16 becomes 0. There is 4y1 minus y2 is equal to 3a e power 3x. There is equation number 3. Given equation is y is equal to a e power 3x plus b e power 4x. Okay. Next, first equation is y1. y1 is equal to 3a e power 3x plus 4b e power 4x. Again, multiply this with 4 and subtract. 4y minus y1, 4y minus y1 is equal to 4 minus 3 is a e power 3x, and then 4 minus 4 gets cancelled. This is equation number 4. What is a e power 3x value? Here it is. So from 3 and 4, what we can write is, from 3 and 4, what we can write is 4y1 minus y2 is equal to 3 times of 4y minus y1. Therefore, this can be written as 4y1 minus y2 is equal to 12y minus 3y1. So I conclude here like this, y2, take this side, then 4y1, if you take like this, it becomes minus 7y1, and then plus 12y is equal to 0. This, so second problem, up third Roman, this is third Roman. Here in third Roman, a sentence is given, a differential equation of the form is given. We have to find the differential equation for the curve, which is given like this. The circle which touches the y-axis at origin. I drawn the circle here. It touches y-axis at origin. Okay. So center lies on normal to the y-axis is x-axis. Certainly normal lies on the normal passes through the center of the circle. According to that condition, if you consider this distance as g units, it becomes g comma 0. So equation of the circle is x square plus y square minus 2gx is equal to 0. Or else if you want to write into x minus g whole square plus y minus 0 whole square is equal to r square. For if you consider this, you can write it as x plus g. So we can write into x square plus y square plus r minus 2gx is equal to, this becomes g square, since radius is equal to g square, plus g square will be there. So g square gets cancelled, plus r minus 2gx. So I wrote only minus 2gx is equal to 0. Now since it contains only one variable g, I can write like this: x square plus y square is equal to 2gx. Right? Differentiate, it becomes 2x plus 2y y1 is equal to 2g. So multiply with the x, you will get the 2x plus 2y y1 is equal to 2gx. From equation 1, what you can write is 2gx is nothing but x square plus y square. I have to multiply with x, no? 2x, right? When you multiply with x, it becomes 2x square, 2x y1 is equal to 2gx. 2gx is nothing but x square plus y square. So answer is 2x y1 is equal to y square. X square minus 2x square is minus x square. So 2xy dy by dx is equal to y square minus x square. That is the solution for this. Equation of the parabola with the lattice rectum 4a and whose axis is parallel to x-axis. We know that any equation whose axis is parallel to x-axis, either like this or like this, anywhere in this plane parallel to x-axis. So I can write in the parabola as, parabola will be of the form whose axis is parallel to x-axis, isn't it? So y minus beta whole square is equal to either plus or minus. Plus or minus 4a, I take only plus 4a into x minus alpha. This is the equation, right? I can differentiate this since it contains two variables. I can write it as 2 into y minus beta into y1. 2 into this into derivative of this is y1 is equal to 4a into x derivative is 1. 4a into x derivative is 1. So this is first equation. This is second equation. Again, if you differentiate, you'll get into 2 into y minus beta into y2 plus, I can cancel here, this becomes 2, so I can delete here, y minus beta into y1 derivative is y2, and then y minus beta derivative is y1 into y1 is equal to 0. Look here, y minus beta into y1 is 2a. So I multiply with the y1. Y minus beta into y1 into y2. This is y1 square. Again I am multiplying with the y1. So it becomes y1 cube is equal to 0. Since y1 minus beta into y1 is 2a, this becomes 2a into y2 plus y1 cube is equal to 0. This is the equation, differential equation. You can try this. Okay, this is the end of formation of a differential equation, forming a differential equation from the given curves. Next session we go for the variable separable method.